let's continue on Chapter 4. We are going to finish Chapter 4 first, and then we will start on Chapter 5. Thursday will be our first exam, right? So we will study those acid-base titrations, which is a technique used to find out like the concentration of one solution. So in the titration process, as you can see from this picture, you usually will take some of those solutions and put in one container, maybe a beaker or flask. So in this example, you can see you have that H plus in this flask. So H plus means acid. And then in this burette, and you put another solution. In this example, you see that is OH1 negative, hydroxide. Now you know hydroxide is the base. Okay? So you have acid here, and you have a base from the burette. And then you are going to add in the base slowly. Okay? Adding very carefully, and here you have same more of H plus and same more of OH1 negative. And at that point, you can see in this picture, your solution become kind of ready to change the color. Because in this container, you also add like a few drops, usually 2 or 3 drops of those indicators besides this H plus. So the indicator depends. So one indicator you choose in this example is colorless in acid. So even though you have the indicator in the flask, at the beginning this flask is acidic, so the indicator don't have any color. So as you adding base in, you have less and less acid, and your solution becomes less and less acidic, become more and more basic. So at one point, your acid, which is represented by H plus, equals your, that means the amount, equals the base. So at that point, precisely your solution is neutral. And then you add in like 1 drop, even like less than 1 drop of those base, and your solution become basic. And in this example, the indicator is the phenolphthalein, which appears as red or pink in basic. So therefore, you can say after you adding like 1 more drop of those OH1 negative, those base, and your solution altogether in this flask become pink or become red. That tells you you already beyond the equivalent point. So if you don't go too much beyond the equivalent point, just a little bit beyond, maybe 1 drop, and then you stop adding solutions, you reading those burettes, see how much you add, and you figure out how much base you add in. Now in this example, so someone did the experiment and tell you, if you take 25 ml of sulfuric acid, H2SO4 in the flask, and then you add in those base. In this example, the base you use is NaOH, but obviously not only NaOH. You can use like KOH or LiOH. So what OH doesn't matter as long as you have those OH, that is the base. So in this example, I tell you, you add 35.0 ml the NaOH, and I also tell you the concentration of NaOH is 0.150 capital M. And we learned before the capital M is the molarity. Right, so now we can use those information, and we know we do the titration, which means we precisely use like 35.0 ml of this 0.150 molar NaOH. Then we know we have the acid, which is 25 ml. Right? So do the calculation for those titrations, or in general, like those so-called stoichiometry calculations, like the first 3 sections, you learn those precipitation reactions. depend on the balanced chemical reaction equation. Okay? So therefore, at beginning of chapter 4, we even studied like a few sections of those writing equation and balance equation. Okay? So let's start from that. And we know we have two reactants. We have this acid in one reactant. We have this is base, another reactant. So now we know we have two reactants, so let's write that up. We will write H2SO4. And usually you will write also the state. We have four common states: liquid, solid, gas, or aqueous. And so then other reactant is NaOH is also aqueous. That's what the typical solution, typical state for titration. Right? So then you know this is the acid-base reaction. Acid-base reaction commonly or in general will produce salt and water. So salt is a combination of the cation from the base. So in this case, the cation from base is Na1 plus. Now you know Na1 plus, if you take Na1 plus as we learned before in those other chapters, okay, and you just write that ready, you want to write the formula, and the salt will produce between the cation from the base and the anion from the acid. So you figure out the cation from the base is Na1 plus, and the anion from the acid is SO4 2 negative. So this the so-called sulfate. Right. So you want to get the formula right because you have to get that right to balance the equation. Okay? So what we did in chapter 3 is switching simplify. So we will switch these two onto Na, so therefore you have Na2. Make sure you don't forget those steps, because otherwise if you have the formula wrong, and you cannot balance the equation. If you don't have a balanced equation, you cannot do the calculations. Right? So therefore you will put Na2 here. And you want to finish the state, and you know you just use the solubility rule. Anything has an Na is soluble, so therefore Na2SO4 is also soluble. And the other product, which is common, which will be H2O, the state, even though this also in this solution, the solution is called aqueous solution, but you don't say that what is aqueous because what is solvent. Right, so once you have this preliminary equation, you want to balance the equation, and you can just use like what we said before, use try and error. One hint I give to you like in chapter 3 is that you start with those atoms in the complex formula first, and leave those atoms that exist as element of the last one balance, but in this one you don't have any free elements, so you can start with any one. And you can examine, like right now we have 2 Na on the right side, so therefore I want to put 2 here, our balanced Na. So then you also like know for each one H plus 1 OH 1 negative, it will produce 1 H2O, right? So you don't have to worry about the SO4. SO4 you can balance that as one atom. You have one SO4 here. You have one SO4 here, so therefore it's balanced. And then what you want to concentrate is those like besides SO4. And besides SO4, I mean in addition to SO4, you have to balance the Na, you have to balance the H, and also balance the OH. Right? So Na we just balance, we put a 2 in front of NaOH, we balance the Na. Then you just work kind of a trick. You examine this equation for every one H plus 1, OH 1 negative produces 2 water. And now if you put a 2 in front of this 2 NaOH, that means you have 2 OH 1 negative. And then from that formula for the sulfuric acid, you have H2SO4. So right now we have 2 of this. Okay? We have 2 of this H plus come from this H2SO4. We have 2 of this, so that comes from we have 2 NaOH. Right? So this gives us 2, and this gives us 2. So therefore you have right now you have 2 H plus and 2 OH 1 negative. So therefore you will produce 2 water. Right? So you will put a 2 here, even though in this calculation it doesn't matter. So now everything is balanced. Right? So do the calculation is about use this equation and use the coefficients and find out the more ratios. So we understand in this problems, those numbers come from titrations, which means you adding enough base, and here you have exactly the more of H plus equals more of OH1 negative. So this is our like understanding. To use those information, what you do, you just figure out how much NaOH you add on, and then convert into the mole of H plus, and then from the mole of H plus, you convert into the mole of H2SO4. The final problems, the outermost question for this problem is to find out the concentration of H2SO4. So you can go like, when you analyze the problem, you see, you want to find out this capital M of H2SO4. By definition, this will equals more of H2SO4 divided by liter of H2SO4 solution. So you can sometimes either going forward to solve the problem, figure out your strategy, or you can going backward to figure out your strategy. So if you want to find out something like from the question, you will say you want to find a molarity of the H2SO4, you just write out an equation, and then you just examine that equation. What do you know? So you want to find out the molarity of H2SO4, you need more of H2SO4, you need a liter of the H2SO4 solution. And this information is kind of simple because you are given how much H2SO4, even though not in liter, and you can convert that very quick, right? So tell you have 25.0 ml of H2SO4 solution. So therefore, this number you can get very quick by take 25.0 ml times like this conversion ratio, and this conversion ratio, I think that's you should very familiar with. You know, like you can always use the equation to find like a conversion ratio. So this ml comes out, and you will get 0.0250 L. Now we kind of like almost solve the problem because we want to have two numbers. We have this number in the denominator. We just have to find out the number on the top. And this is more of H2SO4, which is the more of H2SO4. And that the only information directly gives you is this 25 ml. And then that's what the typical technique. You know, like in a chemical reaction, the H2SO4 react with NaOH. So therefore, you have to think about how can you find out the mole of H2SO4 from the mole of NaOH. And this is why we write the equation at the beginning. So now let's concentrate on how to find out the mole of H2SO4 from the mole of NaOH. So you want to use the mole of NaOH, so therefore you have to first find out what is the mole of NaOH. So we learn in this class there are many different ways to find out the mole of something. If you have the gram, you will use the molar mass. Divide the gram by the molar mass, you get the mole, right? And then in this chapter, we also learn the concentrations. And so you have the concentration, and you have the volume. The concentration in this example is the molarity, which means mole divided by liters. So we studied a few seconds in chapter 4. And so what you do, you will first, depend on like what you prefer. So you can start with this 35.0 ml, and use what I use here, like 1 L is 1,000 ml. And you first cancel out the ml and ml, and you will get how much liters. Right? So you can keep going and until you find out the more of NaOH, because as we think we have that reasoning, we need to use more of NaOH to get more of H2SO4. Right? So the other information is the concentration of NaOH, which is this much capital M. So as we did a few practices at the beginning of this chapter. So if you have this this guy, capital M, you can right away you can write something, or probably I'll use arrow. That's not really doesn't matter. So you have 0.150 more whatever follow this capital M. You will see the more of whatever follow the capital M. Okay? But this 0.150 capital M is for NaOH, so therefore you will see you have this amount more of NaOH. Okay? And so then this is our understanding. Okay? So for every this capital M, you can write something like this. So you can see these kind of details. So that's the reason we use capital M, not use those kind of notations. But in your mind, you know this capital M has those informations. Right? So now what you do, you can take this as the conversion ratios, okay, used in the previous step, and in some step you might have the free weight, and depending on like what you have like from the previous step. So you can try if you put this equation here, you have 0.150 more of NaOH, and you put 1L here. So before this fraction you have that, and then you put this on here, and then you check. So you don't have to worry about if you made some mistake. If you don't cut it out, and then you free weight. If you cut it out, that's good. So that means you make the right choice. Right? So then what you do, you take that, and divide by 1,000, times that, and you get more of NaOH. So you get 0.035 and times 0.15, and you get 0.00525 more of NaOH. Right? So almost there, right? And you need two numbers again. So you need that number, this number, you already have this number, and then right now you almost get that number on the top. Right now you have this more of NaOH. So that's what we learned, kind of what I call the theme of Chapter-4. Chapter-4 is about more to more conversions. Right now you have more of NaOH. And then right here, so you have 0.00525 more of NaOH. And think about how can you get more of H2SO4. What we learn in this class is those conversion fractions. Conversion fraction might come from molar mass, might come from concentrations, might come from density, and then next chapter you will see it might come from some other information. Right? This one you want to convert the more of NaOH into more of H2SO4. So those are different substances, they are different material. Chemistry is about change. Changing from one material to another material. Use another material to react with another material. So we have this equation here, and you can easily find out more ratios. So I want to cancel out more of NaOH, so therefore I will put this more of NaOH here, and we'll put more of H2SO4 there. Now, what will be this number here? So what will be this number here? And what will be this number here? And where we find those informations? Where you find this two question mark? Very good. From the balance equation from the coefficient. Okay? So these two question marks will come from the coefficients of the balance equation. Right, so what is the coefficients in the balance equation for NaOH? Right, so therefore, so this will be our 2, and what is the number for H2SO4 in the balance equation? Is 1. Okay, now let me erase that, so make sure that this is 2 and this is 1. Right? You can see here, right? So NaOH has 2 here. H2SO4 has 1, even though you don't have a number there. Right, so now you see the cancellation, more NaOH, more NaOH comes out. Right? So you divide the number, you will get 0.0026 and 25. Right? Right, now you have both numbers, you have both informations. So let's just continue with this equation now. We just find out the mole of H2SO4 is 0.00, what I said, 2625. Then we already find out the liter from the 25 ml. Right? So this is 0.0250. And here is the mole of H2SO4, and here is the liter. That becomes a slide again. Yeah. Right. So what you do, you will take take this 0.002625, right? Divide by 0.025, and you get what? 0.105. So that's the number. Now the unit, so as I said here, circle this in green. Now you have this arrow here, so let me circle that again, arrow, and divide into those moles. When you cross that, you just capital N. Well, I will circle, right? Just more divided by L is capital M. And then you will see capital M for what? Depending on what follows that. Alright. So make sure you practice on those kind of calculations, okay? So this is typical titration problems. Any questions? You understand all those those few like calculations? Okay, good. This section, we can skip that. It's about the gas evolving reactions. Pretty much very similar as 2 other types we studied, that is precipitation and acid base. So that's very similar to that. So we will skip that. So all these three, the gas involving and the acid base and precipitation called the double displacement. You don't have to worry about those names. And so the next pattern is very important because it's dramatically different than the other three. Okay? So in the other three, in the other three, I talk about precipitation is one, acid base is another one, the second one. The gas evolving is the third one, so we did not study that, but all the three has common. So if you know the first two, you can figure out the second one, the third one. In that three reactions, we involving something that you could change. So you change something is about ions. So therefore, what I said in the first few sections, what you do double cross. You write a K, Na on top, OH on the bottom. You said write H2 at the bottom and switch to double switch. So you support the exchange ions. Now in this new reaction type called the oxidation reduction type, you will see like what is really switching or exchanging is not those ions, it's about electrons. It's very, very important too, like in life and in in chemistry, like it's very common chemical reactions. So we are going to study a new type of chemical reaction, which is about exchange or transfer of electrons. Even though in some reaction, the transfer of electrons is clear and clean. You will transfer one electron from one atom to the other atom, In some chemical reaction, the transfer is not clear, not clean. It's kind of you transfer a little bit, but not really completely transferred. You still think about that as transfer. Right? So these reactions, oxidation and reduction, these are two words, but because they always happen together, so one type of atom, or in precisely one atom will oxidize, the other atom will reduce. Maybe they are sometimes different, usually with different type, sometimes they can even have the same type. Right? So therefore, to emphasize these two processes happen together, we combine these two words into like the redox. Well, there are many different ways to define that. If you study some of those very different chemical classes, you will see there are different ways to tell you what is redox reaction. So some class will tell you any chemical reaction that involve oxygen gas is a redox reaction. Well, that is in general that is true. So you will see like in this chapters we can also call that, but we will have a more general rule. We have a rule kind of apply to basically most of the chemical reaction equation. Not only you have the chemical reaction has O2 in it, so let's see first. Study those chemical reactions has O2 in it. One reaction has O2 in it. It's sort of the combustion reaction. And in this example, you can see the combustion of H2 gas with in the presence of oxygen gas and produce H2O. And this kind of reaction is called redox. And you can remember that. You can say, okay, so if I see the chemical reaction has O2 in it, I can call that reaction the redox. Another definition is you will see like, okay, maybe I will not have O2 in it, I will just have metal and non-metal. And that's also true. If you have metal non-metal reaction, so you will have the redox reaction. Because metal will lose electron being oxidized, and non-metal will gain electron being reduced, so that goes together too. So therefore, you have these two common smaller group of redox reactions. One smaller group is chemical reaction has oxygen gas in it, and the other small type is non-metal plus metal chemical reactions. Now from these two smaller groups, you figure out another pattern. You see, what is a redox reaction? We said redox reaction is the transfer of electrons, so then you can see from these two smaller groups of reaction, you figure out what kind of atom lost electron, what kind of atom gain electrons, and then you will see the atom lost electron has been oxidized, the atom gain electron has been reduced. So therefore, you kind of have a complete, a little complete picture. You get those definitions. Alright, so that's our little definition here. So we want to maybe you have a better understanding or better memory. You will see what is oxidation, what is reduction. We'll just use this Leo here. The Leo really not that friendly. So Leo, that means loss electron. L means loss, and E means electron. O means oxidation. And then the gear, the G means gain, E means electron, R means reduction. Right? So this is one way to, this is very common because there's a lot of reaction. You can see clearly the electron loss from those metal atoms, and then those electrons were captured by those non-metal atoms. Right? So in this kind of equation, you can see this Na plus Cl gas produce the table salt, and if you understand, sometimes, as I said before, usually in the chemical reaction you don't write Na plus Cl1 negative, just write NaCl. But in your mind, you know you will say that Na in this product is actually Na ion, and Cl is actually Cl1 negative ion. So then you compare what happened, what before and what happened after. Before you have those Na, which is the atom, free atom, has 11 proton, 11 electron. And then after the chemical reaction, the Na become plus, which means has less negative, which means less electron than the proton. So that's easy to find out, right? So you see like Na become plus from neutral become plus, so therefore Na lost electron. And by definition, lost electron, oxidation. So that means the real lost electron oxidation. Okay? Now that gear means gain electron reduction. So who gained the electron or who like grabbed the electron? Well, you can see the Cl before the reaction is Cl molecule, but in Cl molecule, so you still have those Cl atom. You share the electron, and because you share even, so therefore you don't have any extra electron. You share electron due to the other one give one to you, so therefore you don't have any extra gain. So Cl before the reaction is pretty much neutral atom. After the reaction becomes Cl1 negative ion, so you receive some negative charge. So where you get a negative charge? In chemical reaction, you don't change the number of protons. Okay? So you only change the number of electrons. So electron either like loss or gain. If you get more negative, that means you gain electrons. You gain negative. Right? So Cl gain electrons according to our this smaller definition. Gain means G, electron is E, R reduction. Right? Now, so I said, in general, you have a lot of those chemical reactions, especially those in the organic chemical reaction. Organic has thousands and millions of those chemical reactions. So what you do, like most of them, they are not happening between metal and non-metals. So you have to like see really, how do you know which atom lost electron, which atom gain electron, and in those chemical reactions, the gain and loss not very clean, sharp cut. You just lost electron, the other one just gained the electron. So therefore, we need to have a more general rule to figure out which one has been oxidized, which one has been reduced. So this is sort of the electron bookkeeping. Okay? So the chemist is assign a number to each element in a chemical reaction, and those numbers are called the oxidation state or oxidation number. So there are different ways to call those concepts. And that allows them to determine the electron flow in the chemical reaction. And even though they look like a charge, the ion charge, the Na plus, you see that the Na really like a plus, right? So you have those ions, and you know they have those charge, net charge. So Na is 1 plus, Cl is 1 negative. So the oxidation state looks like that too. You will see, I will give you some formula, you'll find out the carbon, C is +4 or C is like -4. So it looks like, but they are conservatively totally different, not really charged. So oxidation state are imaginary charge assigned based on set of rules. And those ion charge are real charges, and you can measure those charge by measure like those absorption spectrum, and then you can just measure the dipole moments and bond length and so on, so you can calculate how much charge on each atom. Right, so I told you like last week, so if you start beforehand and to memorize some of those basic information, and it will be much easier. Okay? I think those are the process of learning. So you have to, there are 7 different layers of learning. The first layer, which means like the foundation of your knowledge, is to try to memorize. So we have like 5 rules about the oxidation state. Right? This 5 rule has a so-called priority. What that means is you use the first rule to solve the problem. Try that first. If the first rule cannot solve the problem, go to the second rule. So that is very important. You don't jump in. So always try to follow those steps. So now let's learn those rule by rule, and also, we will have some of those problems, have some of those examples. In those examples, I will emphasize those steps. So the first rule is about the free elements. So if you can identify in a problem, you have those atoms, and you see that atom in a free element, then you can give those atoms, give each atom in that problem. The oxidation state is 0. Okay? So for example, if I have this chemical reaction equation at the end, I tell you have 2 Na solid plus Cl2 gas produce 2 NaCl, and you want to assign those numbers, the sort of the state or the oxidation state for each atom in the program. And obviously you have 2 Na, you have 2 Cl. On this side you have also 2 Na, 2 Cl. To assign those numbers, you just use the rules. So the first rule, you just say which one is our free element. If you identify that Na is in the free element, you will say that Na, each Na is 0. Right? Now I will start from this reactant, and by the I will tell you the common way to identify what is the free element and what is the non-free element. Usually the metal writes as just the chemical symbol Na or Ca or like Mg and whatever, or Hg, those those element names by themselves, followed by those usually the metal is S solid, right? Then you know those metal, they exist as a free element. So in this example, that matching our pattern, we have Na, just a chemical symbol, followed by the S is solid, so we have those Na metal. So then we know Na, the oxidation state is 0. Now the second type of those elements, that's not medium body in the middle, but that's, you can consider those as nonmetals. So the other type on the right side are those nonmetals. Nonmetal, usually they are not simply, the formula to represent those nonmetal elements or the free elements, usually not simply those like a carbon. Carbon is okay, so you just write carbon and solid, and maybe in details, solid what? Solid graphite or solid diamond. But most of those non-metal elements, they have some formula. Okay? So as we even saw in Chapter 2, there are 7 diatomic. Okay? So Cl is one of the 7 diatomic. It means they will exist not as a Cl. Okay? So if you tell me there's also Cl by itself, that's also free element. But that's not usual, because in the usual condition, like the room temperature, room pressure, so the chlorine will not exist as a Cl atom that is too reactive. Right? So that's tell us for those nonmetals, usually there are formulas of Cl2, H2, N2O2, those are the also free elements. If you see like sulfur, S8, if you see phosphorus, P4, that also tell you the free element. Right? So once you identify Na is the free element, Cl free element, so therefore both of them has 0. So even though I write Cl2 here, but that means each one Cl is 0. Right? The second rule is monoatomic ion, which means you have those ions. Remember we can classify ion according to positive ion, negative ion. Positive ion we call the cation, negative ion called anion. We have also classified ion according to how many atoms in there. If there's only one atom in there, we call them monoatomic. Okay? If you identify your ion, you have those problems about ion, monoatomic, you very quickly you will see that number is same as the chart number. Okay? Now let's see in this chemical reaction equation at the bottom. So we have a 2 Ag1 plus Zn solid, which is zinc, and produce 2 Ag silver solid, and also plus Na2 plus zinc aqueous. Well, this is the chemical reaction. This is what the chemical reaction used like in the very old those batteries. So oxidation reaction, as I said, is very important. Like basically all those biological process is about oxidation reaction. You digesting glucose and so on, right? Also very important in daily life. You produce electricity by using those chemical reactions. Now here is ion, and here is ion. And like examples, formulas, so there's only like 1 Ag. Okay? And so then sometimes you might have like a 2 Cl, but those are subscript, not really, tell you 2 Cl together, but it's ion. So you have to learn how to identify monatomic or polyatomic. And so monatomic, which means what is the charge for Ag? Just 1 plus. I mean, what is the oxidation state? Just 1 plus. And then what is the oxygen state for Z, for this ZN2 plus and 2 plus? Okay? You already learned those rules from that first rule, so zinc here is the element is 0. And Ag here is the free element also 0. Right? And so these are the first two rules. And obviously a lot of problems you cannot solve with this only these two rules. Okay? So if you cannot solve the problem for your problem, you cannot solve, you cannot get out of your problem from that first two rules, go to rule number 3. Okay? Rule number 3 actually is the starting point, okay? Because rule number 3 by itself cannot really solve the problem. So rule number 3a, 3b will give you an equation. Okay? Right? So then you will see the importance of priority. You starting rule number 3a or 3b, you get an equation. Because rule number 3a, 3b cannot solve the problem by themselves, you have to use the help of other rules. So once you get enough help, make sure you come back to rule number 3. Because otherwise that means you jump in rule number 3, go to other rules. And that's not good. Right? So now what is rule number 3a? Rule number 3a is about those neutral compounds. If you have a neutral compound, for example in this NaCl, okay? And you will know for each element, for each atom in the formula, in the compound, or in the ion, polyatomic ion, and each of them will have this state or number. Okay? So for this rule number 3a, it will tell you all those atoms number adding together for a neutral compound should be 0. Okay? So we already figured out, for example, Na in this NaCl is a +1. And Cl in this NaCl is -1. You have 1 Na, 1 Cl. So therefore 1 times +1 gives you +1. 1 times -1 gives you -1. Adding them together get 0. And that's what it's about. That is a check. If you don't know the number, you can use this equation as a starting point. So that is very, very important. You follow the step, and if you come out to this rule 3, and that usually will give you a starting point. Okay? For example, you want to find out that those let's say those numbers for that CO2, for CO2. What is the oxygen state for carbon? What is the oxygen state for oxygen in this formula? And you try to solve the problem, as I said, just follow rule by rule. Try to use rule number 1. Rule number 1 about free elements. Because this is not a free element, then obviously it's a compound. So therefore, we cannot use rule number 1. Right? And then you say, can I use rule number 2? But rule number 2 is about those monatomic ions. And obviously, this is not even an ion, that's a compound. So therefore, we cannot use rule number 2. Right? So then you just go to the next rule. The next rule is 3. Okay? 3 is about, we have 3A, 3B. Okay? Now 3A is about those neutral compounds. For neutral compound, you know each atom has an oxygen state. So this is rule number 3A tell you all those oxygen states for all the atoms in the formula for the compound adding together equal to 0. Okay? Right? So that will just tell you, let's see, we will use those atoms symbols representing their state. Right? So what I mean is, you know the carbon will have a number or the state, right? But right now we don't know how much is that number or that state. Right? We just identify how many carbon do we have. We have 1 carbon. Right? So then what is the state for 1 carbon? We don't know. We just call that C. Right? So that looks like easier than what the book said. The book said that's the oxygen state of carbon. No, right now we just call that C. The C means the number one find out. Isn't that okay? So this rule number 3, that means the sum. So I emphasize this sum, which means adding together. Okay? So therefore I will say add. Okay? Add to like the other type of atom. The other type of atom is oxygen. Okay? Each one oxygen will have an oxygen state. Okay? Now how many oxygen do we have in this formula? Therefore I will start with 2. Okay? Now 2 times whatever the number for oxygen we don't know yet. but you can just call that as O. Right? So this is what we said here. You are just, the sum of adding together all those oxidation states for all the atoms. Right? So again, we don't know what is the number for carbon, what is the number for O. What I mean is, what is the oxidation state for C, and what is the oxidation state for O? We just call it O and C. Right? And this will tell you, you have to see all the atoms added together. So you will see how many carbon, one carbon, how many O, two O. So therefore, I hold this equation. And then this rule number 3a tell you adding that together or sum together equals 0 for the neutral compound. And CO2 is a neutral compound. So therefore, adding together equals to 0. Right? Now, if you have something like that CO3 2 negative for our carbonate, right? The carbonate is not a polyatomic, not a neutral compound, it's a polyatomic ion. And that means you still cannot solve the problem with rule number 1 because they're not a free element. You cannot solve the problem with rule number 2 because that's not a monatomic ion, this is a polyatomic ion. So therefore, again, you will come out to this 3b. Now 3b is very similar to 3a, so you don't know the number of carbon yet, you don't know the number of oxygen yet, just identify how many carbon do we have in this formula? 1 carbon. And then you will call the number of carbon to C. So that's what we mean by the sum. You sum up for every atom. You have to identify how many atoms are there and what are those atoms. You have carbon there, 1 carbon. And again, this is sum in plus. Now how many O we have in the formula? So now we will see we have 3 times O. This will differ because this will equals not 0. This will equals whatever the child number. If the child number is 91, you will equals 91. If the child number is plus 2, you will equals plus 2. And in this example, your child number is 2 negative, so therefore you will have negative 2. Alright, so this is what about this rule number 3. You set up the equation first. So I emphasize the priority. Right? Let's see, can you solve the problem? Can you really solve the problem to find out what is C, what is O? What is C, what is O? You cannot, if you study liberal bottom algebra, right? This is one equation. In this one equation, you have 2 unknown. You don't know like what is carbon, what is C, what is O, and you cannot have one like a solution. So you have to use the next rule. Okay? But don't use all the next rule because this rule number 3 has a little higher priority than the rule number 4 or 5. So once you have enough information, you come back. If you don't come back, which means you jumping over this rule number 3. Now what time you come back? Now there's 5 rules that works pretty good for those main group elements. Remember we talk about those elements in the group 1A, group 2A, we call them main group. Main groupers equals those A groupers. And so this rule works pretty good for those main group elements. Right? So what I want to say is, so you are just go to the next rule, try to get some help, but don't get all the help and then you find out what is the carbon, what is O. There's some rule, rule number 4, rule number 5 will tell you what is number for O, what is number for C. And if you solve the problem with the other rule, and don't come back and check it, and then you are overthrew out this rule. 3. And 3 has a priority higher than 5. So that's what I want to say. Okay? And so if you have right now you have two variables you don't know carbon, you don't know O. Okay? You find out one first, then come back right away. If you have equation have 3 something you don't know, you have to find out 2 of those, then come back. Okay? So that's the point. right? So now let's try to see what time will come back. We'll use other rule. Rule number 4. Rule number 4 is about group 1A matter and group 2A matter, which is very easy to memorize. What is group 1A matter? Do you know what is group 1A matters? I should write here group 1A. Group 1A matters. What is group 1A matters? Starting with lithium. Group 1A matters is lithium and Na and K and Rb and CS. So if you have these few elements in your problem, you will give them a +1. For these two questions, do we have these 5 elements in it? No, so therefore we have to go in. So once you find one answer, will come back. You don't have any answer yet. So the group 4B is about those group 2A. So I will write 2A here. Now what is group 2A? From the top is the beryllium, then the magnesium, then calcium, then strontium, then barium. So that means if you have those elements in your program, you will give them a +2 right away. Again, for these two programs, do we have that 5 elements in it? No. Right? So therefore we have to keep doing. So rule number 4 cannot help. But there are 5 rules, so the next rule is number 5. Rule number 5 has a table. Like this table has a priority. What that means, the top one, the second one, and third one, those are the priorities. So use the first one first. See, we did not get any help from 4. Then we used 1 by 1. Do we have a fluorine? Do we have fluorine in both of these two programs? No. Do we have H in these two programs? No. Do we have O in these two programs? Yes. So therefore you can see, if you come out to this step, what will be the number for O? What number for O? Can you tell me what is the number, what is the oxidation state? So excuse me for that. I will usually call them the number, but that's much easier to say. So what is the oxidation number or the oxidation state? I simply call them number. What is the number for oxygen if you come to this table? -2. So what you do, you will say like from rule 5, and we get O equals -2. Right? So in this equation, how many unknowns do you know? How many unknowns do you have? How many unknowns in this equation we have? So we have 2 unknowns. So as I said, if you have 2 unknowns, you find out one of those unknowns, come back right away. You leave the one, come back, get it from this equation. If you have 3 unknowns, you will get 3. You will get 2, then come back. So you have 2 unknowns, and from this rule number 5, you get 1 answer. You just come back. Come back in this way. So we don't know carbon yet, so we just keep writing 1 times C plus 2 times what number for O now? Yeah, so -2. And this is still equal to 0. Now this equation is very easy to solve. Right? You have a very simple algebra equation, and if 1 times C plus 2 times -2 equals 0, so then what is C? +4, right? So now you will see C equals +4. Now this C equals +4 not from rule number 5 only, it's from rule number 5 together with rule number 3. So you start with rule number 3, then you go to rule number 5, find out the answer for O, then you come back to this, what is starting from rule number 3, solve that, get C is +4. Alright, similar story for this guy, right? So when you go like rule number 4, you don't have any help, and then you go to rule number 5. So in this problem, CO32 negative, do we have fluorine? Do we have H? Do we have O? Yeah, so then similar story, so we'll see from this, from rule number 5, we get O equals what? negative 2 again. Okay? Once you get one answer, you have in this equation you also have a 2 you don't know. You come back right away, and you will see 1 times C plus 3 times what now? Negative 2. You can find out oxygen negative 2 from this rule number 5. And in this example, it equals to what? Adding together equals to what?
C equals -8.
Negative, yeah. So we just copy that equation, right? We copy that equation from above, right? And then we will substitute this O by what we find out from rule number 5. We get this equation. Right? Now, what do you find for C?
-8.
Negative 8. Okay, I know you find that one. So you have this C, 1 times C is just C, right? And then this is what? So whatever, you see C equals what? So go for that and C is what? Yeah, plus 4. Right? So in these two examples, you get the same number for both carbon and oxygens. That might happen, but right. Well, this is about these 5 rules. Right. So now let's do some of those examples. So in these examples, the first is you want to find out the oxidation state for each CL. For each CL is what? So what's the answer for each one CL? Because there's when you write CL2, that means you have 2 CL. 0. You might write why is 0? The free element. Okay? So I said this is a 0. Okay? So because it's free element. So we have 2 types of free elements. One is those metals. Metals, just simply the metal name with solid. So the other type are those non-metals. Non-metal usually has a formula. So examples NaS and lithium solid and so on. So the non-metal usually have a formula, like the Cl2 gas and H2 gas, right? So those are the common 2 types of free elements. So that's another example is Br2 liquid. So those are the 7 diatomic. I think sometimes you remember the rule easily, but you don't know like what is the free element. If you don't know what is the free element, then it's useless if you just memorize that's 0. What's the question?
The last one?
The Br. Yeah. Br, so this one is the bromine, Br2, the stage in the liquid. Right, so the first question, you have a 2Cl, again you have a 2Cl, so for each Cl, this number is 0. Okay, because it's a free element. Right, so the second type, the second problem is Na1 plus. Any answer? What is the oxidation state? Okay, so it's a plus 1. So you need to write why is it plus 1?
Because the monatomic ion.
Yeah, so because this is the monatomic ion, okay, and this is our rule number 2. Okay. If you identify your ion in the modern atomic, and just use the chart number and as the oxidation state. Right? So just give one extra example. What is the oxidation state for the chlorine in this formula? If I give you something like Cl1 negative, what will be the oxidation state for Cl in this example? -1. If I give you S2 negative, -2. If I give you N3 negative, 3 negative. Just if you identify those monatomic ion, just use the chart number as the oxidation state. Okay, now we'll use another example, see if you understand. What is the number for N and H in this ammonium ion? You have to use what rule? You have to use those rules, right? You cannot figure out right away. You cannot tell me like N is like something, H is something right away. Neither of them probably, one of them probably +1, but you cannot say like from this +1. So you have this KF. So what will be the state for potassium and what will be the state for fluorine in this KF? Can you figure out from rule number 1? Is this a free element? What kind of material we have? Is it free element or it's a compound? It's a compound. You have more than one type of atom. Remember what we studied in Chapter 1? Okay? So this is a compound. So once you identify your metal compound, right, so therefore you cannot use rule number 1 or rule number 2. So you will start on what? Start with rule 3. Now for the free compound, we will start with 3A. Right? So remember what I write here for the CO2? Right? So we don't know the number for potassium yet. We just identify how many K do we have? 1. So therefore 1 times K plus whatever fluorine we have. How many fluorine do we have? So then 1 times F. Right? Now for this neutral compound, the addition of all those oxidation states together should equal to what? Equal to 0. Right? So in this equation, you have the so-called two unknowns. We don't know what is the K. We don't know what is the fluorine. We have two unknowns. You cannot solve the problem. Right? So then what do? We go back to rule number 1. We go to the next rule, right? What is the next rule? Rule number 4A, rule number 4B. What does rule number 4A tell you? Is for those group 1A metals. Do we have a group 1A metal? Do we have a group 1A metal? Which is our group 1A metal? Platinum. If you see group 1A metal in this equation, and you will give that a number right away. So K will equals what number? Plus 1. Okay? Now with this information, you put it back in there. Okay? Alright, so you have a plus 1. So 1 times plus 1 is still plus 1. Right? And plus F. So 1 times F is still 1F. And that equals what? Equal to 0. Okay? Well, I forgot to remind you, you come back right away because you have 2 unknown. Once you find out 1, you come back. Okay? What about if you have a 3 unknown? What time you come back? You find out 2. Okay? And always leave 1 come back because you want to use this equation again. If you find out all the answer, you don't come back, then that's wrong. Alright, so then you solve this equation, F equals what? Okay, I know what you mean. F equals -1, right? Alright, so that's this problem. Any questions? You already see the question for CO2, right? So we already see that. And let's see the next example is SO4 2 negative. SO4 2 negative. Let's ask the question, is a free element? Okay, so no, we'll just write big cross, no. Is a monatomic ion. What is that? Is this SO4? Is SO4 2 negative is an ion or compound? It's an ion. It's an ion. It's an ion. Okay? Yeah. It's an ion. But this is not a monatomic ion. Okay? It's it's a polyatomic ion. So polyatomic ion is very similar as this carbonate, right? Right? So you cannot use rule number 1. You cannot, because it's not a free element. You cannot use rule number 2 because it's not a monatomic ion. You use rule number 3. So rule number 3 will set up an equation, right? So we'll just identify what element in this ion. We have sulfur and oxygen, right? How many sulfur do we have? So just 1 times the sulfur. And then how many oxygen do we have? So we have 4 oxygen. So we just see 1 times S plus 4 times O. And these 3 equals what? So yeah, we're right. So yeah, adding together these 3 equals -2. Okay. So if you have a compound like in this CO2, so compound CO2 has 0 here, so therefore that equals 0. For the polyatomic ion, so whatever the charge, and you add it together equals that charge. If you have +2, you get a +2. If you have -1, you get a -1. Okay. Right. So now, so in this equation, let's say in this equation, how many unknowns do we have? We have 2 unknowns. Okay? So you will come back once you find out 1. Okay? If you have a 3, you come back once you find out 2. You leave 1, come back. You don't find out all then come back. Right. So now let's go on to find out 1 then come back. Because we have 2 unknowns, we'll just find out 1 come back. Okay? So right now you are at 3, rule number 3. You go to the next rule is 4. Okay? Right, so what is rule number 4 again? 4A and 4B. 4A is about what? Group 1A metals. Do we have a group 1A metal? All the non-metals. So group, rule number 4B is about a group 2A metal. We don't have that either, right? So we go to rule number 5. Remember rule number 5 has a table of the F on the top. Do we have F? If you have F, what number will give F? -1. The next element in rule 5 is H. Do we have H in this equation? If you have H, what number will give to H? +1. Now the next one is O. Do we have O? If you have O, and on this step you give O -2. Right? So once you have this information, you carry the information and come back. So you have S plus 4 times -2 equals -2. Right? And solve this, you get S equals what? Right, so here you will write +6 on top of S. And you will write -2 on top of O. And those numbers just tell you for each one atom. So even though you write -2 on top of that 4O, this -2 is for 1O. Alright, any questions? So the next one is K2 and O2. Now let's ask the question again. Is this a free element? Free element? No. Is this a monatomic ion? Well, even ion, you don't have any charge. Right? What is this? A neutral. When I see compound, I usually omitting this word. I usually omit that neutral. I know you know that's neutral, right? So the neutral compound. Right? So what are you starting from? You will start with rule 3a. Okay, so 3a need you to identify in this neutral compound what element do you have. We have a K and we have O. Right? So how many K do we have? So 2 times K plus how many O do we have? Okay. Now the problem is you will get confused. Adding together from equal to what? Equal to 0. Equal to 0. Okay. Why is it 0? Well, it's neutral. Okay. If it's ion, it equals whatever the charge for the ion. Right? So that's it. So that's rule number 3. It's very simple, right? And so then let's go to the next rule, try to get some help. How many help shall we get before then we come back? How many unknown we have? 2 unknown. So how many help we shall get and then come back?
1.
Just get my number and then come back right away. Okay? So you just go to the next rule. What's the next rule is about 4a. So do we have any element? 4 is about group 1a metals. Do we have any of those elements in the group 1a metals?
Yeah.
What is that?
Yes.
Platinum, that's K. Okay? If you have K, if you have Li, if you have Na, you just give them a number right away. What number shall we give to them? Plus 1. So once you have the plus 1, okay, you carry the plus 1 here and substitute it back into the equation, and you have 2 times plus 1 plus 2 times O. You still don't know O yet, but that's okay because you have an equation. Alright, so you solve this equation and you find out O equals what?
-1.
Very good, very good. See, you can do it. 81. That's not usual. Okay? That's not usual. And that also makes you become alert. Okay? If you forget, you go all the way. Okay? You know, rule number 4 tells you K is plus 1, and then you go to rule number 5, you find out O is -2. Then you get the answer, you get it wrong. Right? So the right answer is, so here you are writing plus 1 here, which means for each 1K, okay, you are writing -1 here for each 1 O. That's not usual. Obviously, usually -2. Okay? You will also get -2 if you don't follow the procedure carefully. Right. I think that's recorded. Just hold on result. That's like you should like memorize those very easily. And do a CRE. Okay. So the question, all these 3 questions are not that easy. Okay. You need to set up all those equations. And one of that, you have to get 2 help before you come back. I'd like to see that. You start with rule number 3, right? And you have 2H, so you have 2 times H, and plus how many phosphorus you have. This is 1P plus 1P. Then you see how many O do you have, right? Adding all those numbers together, be careful with that. What are the charge on that? if your problem is a neutral compound, it's equal to 0, right? If your problem is a ion, that will equal the charge on ion. Okay, so how many can you use rule number 1? Is that elements? This H2 and Q4 1 negative elements? No, because you have more than one atom, more than one type of atom in it, right? So then you have to start with rule number 3.
Is the answer C?
Well, on another A. So you will see this pretty good. You see, first don't assume any number. Don't use your previous knowledge at all. You just follow the rule. How you cannot get those answers from rule number 1 or rule number 2, right? You have to start with rule number 3. What do we call this? Is it a compound or ion?
This is iron.
This is ion.
Yeah.
Altogether is ion. Altogether, you have 2H.
So it's 2 minus here.
You just don't change the problem. Just one minus, one negative. You have H2PO4, just one negative, right?
I thought it was just 2 plus, that's 2.
You don't worry about the 2 plus and 2 negative yet. Just identify this the positive atomic ion. The charge is -1. That's the problem gives you, right? So then the next step, you decide how to use rule number 3. Just see how many H do we have, how many phosphorus do we have, how many oxygen do we have.
Is this right?
Right? So you don't use as I say, you don't see like H, you reply just equal plus, you are right, but you want to make sure you are right. And see in the last example, like oxygen most of the time -2, but in that line -1, right? So you just have to follow the procedure. So you just write our equation, you have 2 times H, so 2H plus 1. Don't write 1, you don't know the 1. You assume you don't know, just write 2H. You already have 2H. You already have that 2H. 2 times H. How many P do you have? Just plus 1 P. And how many O do you have? Then plus 4O, 4 times O. And adding together so equal to what?
Oh.
Whatever the charge, -1. Very good. And then you go to the next rule. Right now you have how many we don't know? 1 we don't know, P we don't know, 8 we don't know, we have 3 we don't know. So what you need to do, you want to find out 2 of them and come back. Right? Because this equation has 3. And usual algebra equation can only tell you like 1 unknown. So you have to do all the rule and find out 2 of those answers and come back. Okay, now what is next rule? This is what you get from 3. Next one is 4. You forget about those, just think about the rule now. What is rule number 4 tell you?
Yeah, I got C.
Huh? Look at how you like those. Okay, so the answer is what?
C.
Answer is C. Right? So answer is C. Okay? I will just do like one problem for you because we don't have that before. Okay? I'll do this one for you. I will do this one. Okay? Now, what carefully? What is this? Is this a free element? Is this a monatomic ion? No. So you start with rule number 3. Okay? So you will see how many we have H in H, and we have a P in H, we have a O in H. You don't use your previous impression. Most of the time you will say H is +1 and all things -2. Forget about those. Okay? Every time you start with fresh, clean, new. Every time you don't know anything. Okay? Just know those rules. Right? So you have these 3 elements, adding together sure equals either 0 or whatever the charge number. Okay? So let's identify how many H do we have. So I will write a 2, because we have 2H. Then plus, how many P do we have? How many phosphorus do we have? 2, 1. So therefore that's it. How many oxygen do we have? 4, so there are 4 O. Not 40, 4 O. Now this will equals what? There you go. Whatever the number tell you is on this corner here. Okay? If negative 1, negative 1, negative 2, negative 2, plus 1, plus 1. If it tells 0, that means 0. Okay? So that's it. So you will see this equation, how many those guys in algebra, how many unknowns do we have? We have 3. We have 3 unknowns. Okay? Now you have to see, you have to go all the way to some other rules to get 2 answers that come back. If you get 1 answer come back, not enough help. Okay? If you get 3 answers come back, you're too much help. Right? So let's go to the next rule. Next rule is 4. Do we have any help from a 4? Yeah, that's the problem, because that's the beginning. You see, rule number 4A is about group 1A metals. We don't have any group 1A metals. Okay? Rule number 4B is about group 2A metals. We don't have those metals in it. Okay? So let's go to rule number 5. Rule number 5, I will write on top. Do we have F? If you have F, you will see that will be negative 1. Do we have H? If we have H, I will tell you it's plus 1. We have H. Yes, so therefore you will see the plus 1 here. So I will write under here. Right. Do you have O? The next one is O.
Yes.
Yeah, so negative 2. The next rule, just in case, you have a 7A, and 6A, and 5A. Right? I just tell you, you don't go all the way, because you go all the way, you will find the answer for this, also for the B. Because P is in what group? 5A. Then you will give that a 5A, it will be negative 3. Then you are totally against what you call that swap. So you don't like, you have to know like what time you come back, what time you have enough information. Okay? So we have enough information now. We just use 2. Okay? You don't find all the answers from this rule, then come back. I mean, you don't come back to rule 3. Right, so you will find out, so you have 2 times plus 1 and 2. Okay? Then plus P, you don't know. Then plus negative 8 equals negative 1. And obviously you solve this equation, you get P equals what? Equals plus 5. Alright, the question about ask this guy, not ask you H at all, but you have to use H and O to find out what is P. Alright, so the answer is C. You do the similar practice for the other 2. Right? You probably get, I think most of you get it pretty good. If you feel liver not that comfortable, not that solid, do more practice. Okay? Okay, so I'm going on to the next one. Right? All right. Okay. So which one is redox reaction? Okay. Redox reaction, okay. Well, tell you something like this. Has elements oxidation state change. Okay. So if you have those kind of reaction equations, okay, so that's why we start those oxidation state. Okay? just identify what is the oxygen state for all those atoms before the reaction, and then you will also find out what are the oxygen states for those atoms after the reaction. Okay? If all those elements' oxidation states before the reaction, after the reaction are the same, then your reaction is not a redox reaction. What did you say?
D,
Very good, very good. How do you know that's D?
because O2 in the first part is the charge is 0, and in the second part it's -2.
Very good, very good. Yeah. So usually you will see, remember we have that at this first section, for those one smaller group of redox reaction, is those chemical reaction reacting with oxygen gas. Okay? Or another smaller group is metal reacting with non-metal. Okay? So that is like in those kind of like very not a numerical way. Okay? Very good. You use numerical way, just use the oxygen state, and you see this is the free element, that's 0. And then in this one, you can use like very similar what I did for the CO2 to find out. So in this H2O, this is -2. In this NO3, it's also -2 for O. If you find out, if I give you the question right, if you find out one element's oxidation state change, there must be another atom or another element that never also change. So they always occur in pairs. Alright. So you can also check all other chemical reactions, make sure you do that. Okay? But that's a good practice to practice those memorize the rules. Yeah.
So you find the net overall oxidation charge for the.
You can do that, but that's one extra step. What you do, just find the number for each atom before the reaction, after the reaction. Okay? So let's see, I will give my example for the first one. Okay? So the answer is D. Okay? Now what I use is get the number for each atom. Okay? So let's get a number for this H and Br in the first one. Okay? We cannot use rule number 1 or rule number 2 because this is compound. Okay? So you just start with 1H plus 1Br equals 0. Right? Then what you do, go to the next rule, get some help. And you will sure get one help, then come back, because in this equation you have 2 you don't know. Okay? So if you find out H first, come back. You find out Br first, come back, depending on what are the next rule. Okay? So where do you get this equation from? Where do you get this equation from? From which rule you get this equation? 3. Okay? Next rule is 4. 4 is about metals. Do we have any metal in here? No, so therefore you go to rule number 5. Rule number 5 has F first. Do we have F? Second one is H. Do we have H? So if you have H and you go to rule number 5, it will tell you H is plus 1. Okay? So you carry the information H equals to plus 1 here. You get this H equals to plus 1 from rule 5. Okay? Then you will see 1, so you just replace the H by 1, plus Br equal to 0. Then that tells you Br -1. So you write the plus 1 here, -1 here. This number at our convention is for each one atom. So even though sometimes in the formula you have 2H, you have 2O or 4O, but those numbers is for each one. Okay? Right, so then next, let's go on to this one. Right? Similar, can you say this is a free element? Is the KOH a free element? No. Is that an ion? No, it's a compound. Right? So again, you have to use rule number 3. So rule number 3. Okay? And we identify we have platinum in it, we have oxygen in it, we have H in it. So how many K do we have? 1 K. How many O do we have? 1 O. How many H do we have? 1 H. And these are adding together equals what? Very good. Now you know something that is. So it's 0 because this is a neutral compound. You don't have any charge here. Okay? So if you don't have any charge, adding together equal to 0. Right? So now you have to go, and here you get two answers coming back for this question, because we have three something we don't know. Right? Right? So let's go to the other rule. Get this from rule number, so we use 4 and maybe 5. Can we get any help from rule number 4?
Yes.
Yeah. From rule number 4, you will get k is 1 plus 1. Okay? Right? So then let's go on. And that's all the help we get from rule number 4. Right? Rule number 5, F on the top, H is the second, and O is third. So therefore, what you will get first? You get H first. Okay? And H will be also 1. Right, so 1 plus O plus 1 equals 0. 0, that means 0. So therefore, this tells you O equals what? In this case, coincident also you can get that from that. But you don't like do that. So you have plus 1 and negative 2 and plus 1. Understand? Okay? So keep going, right? And what number you can get? Oh, that's not good. How can you solve that problem for H2O? Is that a free element? Is iron? H2 is iron? No. Right? So now let's use this. So what do you do? What shall you use? What the rules should you starting from to solve the problem for H2O? Rule number 3, right? So how, we have H, we have O. How many H we have there?
2.
So yes, you see 2 times H. Now plus, how many O we have there? 1 O, just 1 O. And that's what equals what? For H2O, for this problem of H2O equals 0. Right? Right. So then you have to go to the other rules, because this you get from 3. Right? Right. So you get this, you starting from rule 3a. Right? And then let's go to like rule number 4. 4a is about those lithium and Na and potassium and rubidium and cesium. Do we have those guys in it? Rule number 4b is like beryllium and magnesium and calcium and strontium and barium. Do we have those guys in it? No. So you have to use the rule 5. Do we have F? If you have F, you will give negative 1. Do you have H? You have H, you give plus 1, so therefore this will be plus 1. So you have 2 times plus 1 plus O equal to 0. So O equal to what? Negative 2. Okay? You can see we come back once we get that H. Right? So therefore we have plus 1 and negative 2 here. Similarly for this one, now K will be plus 1 and BR will be negative 1. Right? So again, all those numbers we write here is for each one atom. Now what I said before is you examine those numbers, does any atom has number change? Does H's number change? Before the reaction, what number we have for H? Plus 1, and plus 1, and no change for H. You examine that's true for every atom. If you don't have any number change, your reaction is not a redox. If any number change, usually that will appear in pairs. Right, so that's how we find out the answer, I think, and what you find out very quick. You find out that for D, the oxygen from 0 change into negative 2, so that's one answer. Right, so I think as I said before, chemistry is not difficult. You have to spend time in it. Manage your life. How much time you put into study, and study what? So usually, if you start study liberal early, that will release a lot of anxiety and make you feel better. Right, so I think you are, you know, like, from, you should be able to study. So now let's study more concept about this section. And so as I said, you can use that Leo gear. Okay? Leo gear. Okay? You use that, they kind of small because you have to know which atom lost electron. If the atom lost electron, that atom has been oxidized. If the atom gained electron, that atom has been reduced. That is only a smaller group of chemical reaction you can do, because some chemical reaction you cannot see clearly which atom lost electron, which atom gained electron. Now we are going to use a more general rule, is use what we just said, sign the number for each atom in the chemical reaction. What number we talk about is those oxidation state. Okay? So once you have the oxidation state, and for those atoms whose oxidation state increases, which means that atom has been oxidized. Okay? And then do similar, if you find out some of the atoms whose number, again what I mean by the number is their oxidation state. If their oxidation state decreases, then that atom has been reduced. And this is very, very general. Not only for that chemical reaction, you can see the electron transfer for any chemical reaction. Okay? Now, if you examine this chemical reaction and use the rule we just studied, you can sign those numbers very quick. So this carbon here will be -4, and this will be +1. Well, that's kind of what I did opposite. No, I at the bottom. So this is 0, so this becomes like a +4, and this is -2, this is +1, this is -2. If I give you those numbers, you just use what we see in these two statements, they tell me which atom or which element has been oxidized. Atom has been oxidized, which means the atom number going from left to the right increases. Carbon. Carbon go from -4 to what? +4, so the number increases. So therefore, carbon, that element, has been oxidized. Okay? So that always appears in pairs, unless I do something wrong. And if one atom has been oxidized, there must be another atom has been reduced. The atom has been reduced, you can find out very quick. Use number, whoever the number decreases. So what element in this program the number decreases? Oxygen. Oxygen from 0 to what? -2. In both these two compounds become -2. Alright, so therefore oxygen in the so-called those terminologies has been reduced. Your number decreases. Or you can say your number reduced. Your number reduced, your element reduced. This just tell you like a very general rule. Okay? Now we are going to study like another called agent. Okay? So the reactant that reduce an element in another reactant is called a reducing agent. Reducing agent is reducing something else. How is something else being reduced? That means gain electrons, or the number decreases. So therefore, those reducing agents are those guys that give out electrons. If you give out electrons, what happens to you is oxidized. Right? So therefore, the reducing agent will have those elements that is oxidized. It's kind of opposite. So you learn step by step. Once you identify which atom has been oxidized, then that reactant has that atom that has been oxidized from our reducing agent. Because reducing agent is the guy or the reactant that is reducing something else. That's very simple memory. You just spend some time and do that. Okay? So if I give this chemical reaction equations, so the other one is opposite. Okay? So oxidizing agent is oxidizing something else, which means grab electron from something else. Okay? So if you have those chemical reactant, and in your chemical reactant you have those atoms in H, those atoms, and you grab some electron from somewhere else, and then all together you add a group of, you will call that you are the so-called oxidizing agent. So oxidizing agent have some atom in H that have been reduced. So let's use this example and do a practice. We will first find out which atom has been oxidized. If the atom has been oxidized, then that reactants has the atom will be our reducing agent. Let's find out in this kind of reaction by using the number. I will give the number very quick. You can find out the number very quickly either. What is our so-called number, actually the so-called oxygen state for Na? 0. Before the reaction is 0. And before the reaction, what is the oxygen state for Cl, for each one Cl? It's also 0. Now after the reaction, what is the number for Na? +1. And for Cl, -1. So now you can use the number, whoever number increases, who is being oxidized, whoever number decreases, who is being reduced. So who is oxidized? Then Na is oxidized. If Na is oxidized, if something has an Na, it's called a reducing agent. So who is the reducing agent? So Na matter. The other one is also true. So whoever has been reduced will be our oxidizing agent. Who is reduced in this reaction? Whoever number decreases, the Cl go from 0 to -1, being reduced, right? Right. So if your element, if you have a reactant, your atom has been reduced, then your reactant is the so-called oxidizing agent. So who is our oxidizing agent? The Cl2. Right. So you can do this again very quick. So this problem is identify who is oxidized, who is reduced. That's very simple. You just find the number, whoever number increases will be oxidized, whoever number decreases reduced. Right? So what is the number for MTS on the left side? 0. Very good. So this is 0. Right? Then we will get a number for H and for O in H2O, and you do those practice, and then you find out. But I said you don't memorize. I memorize because I know this is right. So this H is what? +1, this O is what? -2. And now you do the similar. So now here the Mg become what?
+2.
The Mg become +2 here, and you can use that rule number 4, you find that very quick. And the O is still -2. H will be +1. Understand? Now here H will be what? Okay, very good. Okay. So what element has been oxidized? Magnesium. Can say magnesium, very good. Magnesium go from 0 to +2, obviously +2 is not than 0, so your number increases. If your number increases, your element has been oxidized, right? So what element has been reduced? What atom has been reduced? Hydrogen. So H has, you are precise. So later on we'll see the agent, we'll see them together, right? So H from +1, which is that number, and go to 0, so your number decreases, your number reduces, then your atom being reduced. That's very easy to say, right? Right. So magnesium has been oxidized and H has been reduced. So that's the answer, right? And if you do one step, you will see what about those agents. So what kind of agent is this Mg? Remember, very good. Mg has been oxidized, and the agent is what they do. What they do is actually what they get. You know, if they have been reduced, and this will be the oxidized agent. If this has been oxidized, it will be the reducing agent. Right? Now we know H is the atom has been reduced, right? So then the oxidizing agent will have, those are the reactants, will have the atom that has been reduced, right? So who has atom that has been reduced? Is H2O, right? So H2O together is our oxidizing agent, because in H2O we have H in it, and H has been reduced, right? So that is about those concepts. Right, now here, see like, first decide if the chemical reaction is an oxidation reduction reaction. If they are, identify what is our reducing agent, what is our oxidizing agent. See, the first question is about whether the chemical reaction is redox or not. To find that out, you just figure out the number for each atom. If the number changes for any atom, there will be a pair. Then your reaction is redox. Alright, so let's find out the first one. What is the number for MEG right now on the left side? 0. What is the number for O in this left side? 0. Okay. Very good. So then what is the number for MEG on the right side? From rule number 4. Okay? And then this O will be -2. Okay? So we have any number change. Yeah, we have MEG go from 0 to +2. We have O from 0 to -2. Right? Alright, so what atom has been oxidized? Magnesium number increases. What atom has been reduced? Oxygen. Okay? So now what is our reducing agent? Mg. Right? What is our oxidizing agent? O2. Right? Very good. So keep going. Let's go to the second reaction. Okay? Second reaction I think we did that before. So this H is what? +1, and Br is -1, and this calcium will be +2, O is -2, and H will be +1, and +1 again, -2 again, and +2 again, -1 again. You also check, you can do the practice, you find those numbers. If I have those numbers, you tell me if this reaction 2 is a redox reaction or not. No. Any number, all the atoms still have the same number, right? So the second reaction is not a redox. Not a redox. Because all the elements number before the reaction, after the reaction are the same. Alright, now let's go on to the last one, to C. Right? What is the number for zinc on the left side? 0, because this is a free element. Okay? And this is also easy. What do we call this ion? Monatomic. So therefore this is what? +2. Okay? What is this number for zinc? That's also true, +2. Right? And what is the number for Fe? 0. Very, very simple. That's probably this. You can just use rule number 1 and number 2 to find out the answer. Now let's find out what atom has been oxidized. The zinc again. Cn changed from 0 to +2, so that we said if the element number increases, so that atom has been oxidized. What has been reduced? The Fe. Fe go from +2 to 0. Now what is our reducing agent? The zinc. What is our oxidizing agent? The Fe 2+. Right. So that's about those practice. Now you find out in this kind of reaction, what is the reducing agent? You want to find the reducing agent, you have to find out which atom has been oxidized. Then those reactants has atom has been oxidized for their reducing agent. So find the number very quick for each atom. What is the number for Zn on the left side?
Please come up with work real quick, my question. This is gonna work for this one. How this gonna work?
On the work for that one?
Yeah.
Let's see, you have Mn and O, and another O, and another H. This is not a free element, right? It's a compound. What you do, you don't, this two, not that two. That two is a coefficient. So those numbers we use, you just need the subscript. You don't have one element.
Oh, you don't use this at all?
You don't use that at all. So you have Mn, one Mn. You have two O's. That's the element.
So in this one, you use this coefficient.
Yeah, just forget about coefficient. Just don't use the coefficient at all. Just the coefficient just use like those conversions. Yeah. So you have mn, 1mn plus 2o plus 1h equals 0. And then you find out this is only the beginning. Then you just have to go to the next room, find out 2 answers and come back.
Good enough.
Very good, that's 0, right? And then those you have to find out and use, so that's important to memorize. Otherwise, you have to use for this one, you have to use that, use those rule number 3. So you see, you have mn over 2, right? Mn over 2, and the sign is rule number 3. So now you don't know what is the number for mn. You don't know the number for o. Don't use those coefficients. Don't worry about the coefficients. Just say those subscript in the formula. So how many mn do we have? 1, just mn plus, how many o do we have? 2, plus 2o equals 0, because this is a neutral compound. No, equal to 0, you have something like this. So you have mn, right? mnO2, right? And you have 1 mn, just say 1 mn, right? And then plus whatever o, how many o do you have? 2. And this is sort of the neutral compound. You don't see like that, CO3 negative, that charge. You don't have any charge here, therefore that is equal to 0.
Because
You have this equation. Let's do some practice. How to practice the equation, right? Once you have the equation, and you start with the equation, very, very important.
is it A?
Yeah. So now MA is positive. MA is positive because the 2 times negative 2. Yeah, now you just all right, so the answer is A, right?
Yeah.
All right, okay, I think that's about Chapter-4, right? Okay. So turn in the scantron for Chapter-4 and pick up the scantron for Chapter-1 and 3, and we'll start on Chapter-5. Okay, so put that Chapter-4 here. Just don't like
This is the last question, correct?
yeah, that's not a question.
Or for the test, are we going to take the test and just leave?
We do the test and then we'll get some more lecture on Chapter-5, then we'll do that. The lab is the acid-base titration, that's what we started.
Oh, okay, so we're going to try to neutralize it.
Yeah.
I'm doing like
Yeah, just
Oh, thanks. I just thought notes, I thought we were done.
Doing Chapter-5 notes.
Okay, so
Oh,
let's start on
It's
Chapter
green
5.
tea mixed with matcha powder. No. I'm working there for a while, so I just kind of like.
Okay, so Chapter 5 is about the gases. Okay? And we will study first of those, we first will study a few of those law about the gases. So then you will see some of those we studied before, like those more and more ratios, and that were ideas again in this chapter. Okay? So before we do those kind of like review what we did in Chapter 3, Chapter 4, we will study those property of gas first. Well, gas is kind of unique state. So in reality, those real gases is kind of complicated. So in this chapter, we will see those gases are ideal. Ideal gases. What do we mean by ideal gases? Well, ideal gases has, for the ideal gases, there are two important assumptions. So this has two important assumptions. And one is no interaction between gas particles. Second, no volume for gas particles. Or those gas particles do not take any volume. Now, obviously, that's not true. You don't fill the gas particle as volume. For example, we have air. Air is a gas. And there's a gas particle in the air. There's oxygen gas and nitrogen gas. You don't fill them, but if you condense them, you will see there are certain volume of those gas. So in the study we have, like in this chapter, we assume these two important assumptions. And so then I will also mention, for the ideal gas, we will have that four variables. Four variables, we are going to use those four variables to describe those gases. What are the four variables? The four variables will be the P for pressure, T for temperature, and V for volume. And then how much gas do we have is so-called amount. Amount in this chapter, usually you will use the so-called N, and N representing how much moles. So this will be our study, this chapter 5. So you will see this few of the law will tell you the relation between some of those variables, maybe not all those variables, depending on what experiment we have, what law we have. Right? So we know we have to use these four variables: P for pressure, T for temperature, V for volume, and N for how much mole. And I think some of those variables we already studied before. You know how to find out mole, and you know how to convert volume from liter into milliliters.
And then you also know like the temperature from Chapter-1, how to converting from Fahrenheit to Celsius, from Celsius to Kelvins. So let's begin this chapter by studying the quantity we are not familiar with, the so-called pressure. Why we will have the pressure from the gas? Because gas is a very special state, and in gas state, all those particles, maybe atom, maybe molecular, are freely moving, relatively freely. If ideal gas is completely free, there's no attraction at all. And so therefore, when they are always moving, they might colliding with the container of the surface of the container. If that happens, the collision will have some sort of force on it, so it kind of have the push on the surface. Then push is the force, and you have the force, and you have you can divide by how much area, then you get the pressure. Right? So we have to get familiar with those different quantities, okay? And what unit we have, what unit shall we use. So pressure is produced by the collision of those particles in the gas with the container. Then the problem how we measure that. Okay? The modern technology can use those electronic devices and measure what the pressure. The first instrument invented by a human being about 400 years ago is this barometer. So what they did is take one of those glass tube, fill the glass tube with some of those liquids, and obviously you can use water, you can use alcohol, you can use salty water, depending on the density. So you want to use the density that's higher than this. Your glass tube don't have to be that long to see the change. So they use mercury. Mercury density is very high, about 13.5 grams per ml. So you fill up this glass tube with mercury, then you have another container, maybe a small beaker or something, also have the mercury. You invert it over, the mercury try to fall out, and then the air pressure try to push it up. So at some point you have the equilibrium. Then by reading what is the height of this mercury column in the tube, you will find out what is air pressure. So then this air pressure usually is measured by the length of this mercury column. So therefore you have this millimeter mercury, or simply call them mmHg, so that's 1 unit. And you can also use how much inch Hg, so that's another unit. So then there are many different units. So you are use what you learn in Chapter-1, Chapter-2 again. If you have those different units, you will know the equation between those different units. Then you can do the conversion. So the first few problems in this chapter again is about converting between those pressures. So I will give you a few pressure units here, and all those pressures represent all those different numbers representing the air pressure at sea level. So we always talk about the atmospheric pressure, like how many atm. So average over history at the sea level. So the usual air pressure is kind of the standard called 1 atm. That 1 atm can representing by different units, can representing by millimeter mercury. So instead of say 1 atm, you can see like 760 mmHg. Or you can see 29.92 inch Hg column. So let's skip some of those steps, and we can say this table again give you all those different units and different numbers. They are all equivalent because they are all representing the same pressure. Okay? So therefore, from this equation, you can figure out 1 atm in here, 1 atm exactly. Okay? if you want to find out the relation between ATM as in that what number the PSI, which is standing for pound per square inch. You have to read those numbers, so that PSI has a number of 14.7, and then you find out this relation of this equation. So once you have this equation, you can use this equation and get the conversion ratios, so therefore we can convert between ATM and PSI. Right, now let's do a practice. So in this practice, if I tell you like one pressure is 132 psi, and you want to find out how much millimeter of mercury, that requires you to know the connection or the relation between psi and mmHg. Okay? Do we know this connection between psi and mmHg? If we know that, we can use one conversion fraction and find out. If we don't, we have to find out an intermediate. Right? So as you recall or think about the last table, in the last table, every those units are the same. I mean, every those number of different units are the same, which means 1 ATM. So all are connected to 1 ATM. So you can use ATM as the intermediate. You have probably put here one of those intermediate, because you don't know this connection right away. You don't know 1 psi or how many psi is how many millimeter mercury. Okay? Right. So therefore, you want to go from the psi to ATM first. So our intermediate will be the ATM. As I said in the last table, everything is connected to the ATM. Okay? So then you can go from ATM to this millimeter of mercury. So therefore, we have two steps. Okay? Our step 1, our step 2. Okay? So in step 1, we will use 1 ATM equals 14.7 psi as right there. And then in 2, you want to use 1 ATM, if you recall in the last table, equals 760 millimeter mercury. So now you go back to what you learned before, like in this class. It's very important to find out those relations, and use the relation and find out the conversion fractions. So you write up, you just 132 psi. You have the psi. You want to cancel out the psi, so therefore you want to put the psi as the opposite. And then the second one is again will be opposite. Right, so that's our problem. PSI cancel out, and ATM cancel out, and you get the mercury, millimeter mercury. So you have 132 divided by 14.7 times 760. Maybe that's not a long number. So 68.94 millimeter mercury. All right. Any questions? All right. Now you do a practice. Right. So I give you the inch mercury. You want to get psi. This is together. This is the inch mercury. So
intermediate is 18N or 1 ATM. So I'll give you three equations. 1 ATM equals 29.92 inch mercury. You also know 1 ATM equals, from the last problem, 14.7 psi. Right? Okay, so what do you find out? What's the answer? Right? E, last one, right? So you write out something like this. I'll go very quick because it's kind of review, right? So we'll have the inch Hg, and our first one will be 29.92 inch Hg, then 1 ATM. Then the second one will be 1 ATM equals 14.7 psi. And you see that you change the candle out, and candle out, right? So the answer is 16.7 psi.
Can we start from number 51?
Yeah, let's start on 51. Right? So 51 on the back, and then you just write that for Chapter-5. Okay, another instrument is about measure the pressure of a gas in a container. Okay? And you can see this is sort of the manometer. Okay? So here the container has a gas in it. Okay? Obviously you can use those electronic devices to measure what the pressure of that. The very ancient technique is use a tube, a glass tube, has those kind of shape. And you fill the glass tube with some of those liquids, depending on how many pressure you have. Better use mercury. Okay? And so then, depending on the pressure of the gas, compare that pressure with this pressure. This pressure here is this end is open to the air, which is the air pressure. Okay? So if the gas pressure is larger than the air pressure, and then the gas can push out some of the liquids. So on this side of the arm, your liquid is less. On the other side, you have more liquid. So depending on which side has more liquids, which side has less liquid, depending on whether this is open to the air or not, and you can find out the pressure of the gas in the container. So that's a little different than our barometers. So on the first instrument, the barometers, you use just a very straight glass tube. One end is closed, the other one end is open. You fill that with mercury, flip it over, and then that will measure the air pressures. So let's do like a few of those possibilities of using the manometers to measure like those gas pressures, depending on what our gas pressure. And so even though you might have a different those setup or those different scenarios, the principle you follow is similar. So principle is like this. If you study those physics, sort of the fluid mechanics, so when you have one body of liquid and at the same depth,
the same depth of one body of liquid, and you know, according to the mechanics of a fluid, you have the same pressure. You draw the line here, okay? So this is at the same depth. So this U-shaped tube has liquid in it, okay? And obviously, so that is the surface, and this is the surface. You have a different depth, okay? So here is one depth, okay? And here is the depth. You have different, like just like as you have those swimming pool waters, you have different levels, okay? So at the same level, in the liquid, you have the same pressure, okay? So let's see if this pressure and this pressure here are indicated by these two arrows and pointing to these two levels. Okay? What is the pressure here on this side? And here we know is gas. So here all gas here. Right? So this part we can call that P gas. So this on this surface here, right on this red line, nothing else, just the gas. Now, what is the pressure on the other side, on the left side? What's the pressure on that red line? Well, there are two parts for that pressure. You're right, so there's one pressure comes from air, right? So air, right now, this end is open, so therefore we have the air pressure. The air pressure will push on that top layer. Okay? Then one by one, all the others will also push on that level. But in addition to the air above this red line here, okay, maybe I will change that into a different plane. So I will change that into a blue line there. Okay. So above that blue line there, you not only have the liquid, you have the air. Okay. So if I call that P, and that P equals P air, plus another part of the pressure that comes from the liquid. You agree? And that's from the liquid, so this from the liquid, so this part of the liquid also produces pressure. We call that pressure is our pH. Because that pressure depends on what is the number for the H. You measure the H, you can see according to this diagram here tell you the H you measure is only the difference between this level here to the top, which means the liquid difference between the two arms. Right? So then you have that pressure on the left side equals, on the left line there, equals P air plus pH. And on the right side, you only have the P gas. And according to the liquid mechanics, so this should equal P gas, because these two are at the same depth. So this is the same principle we're going to use for all those scenarios, depending on what you have, whether you open, whether this side is high, or that side is high. So you see that? Now we have these three, and then repeating that again. Okay? What you do is draw a line, okay, that is at the same depth of the liquid. Okay? So the first one, I will draw a line here. And for the second line, I will draw a line here. I will draw a line here. Why I don't draw here? If I draw there, it doesn't make any sense, because what you want to measure is the gas pressure. You just start with some line, you will have the gas pressure or the air pressure there by themselves. Right? The first one you already know for this setup, right? So you will have that on this side, on the left side, you will have that. That's obviously what you get for the last slide. You have the P gas plus pH equals P air. That's right? Okay? So So when I draw the line, that means the pressure here equals pressure there. Then you will just examine what is the pressure here on this line here. On this surface here, I draw a little low, I should draw right on that top. There's nothing there, there's only the air. Right? So therefore, on this side here, right? If I draw the line there, on that surface, nothing there, but what? What is on that surface there? Air. Right? So therefore, we call that P air. I don't know whether that's important or not, but so that just gives you some of those process of solving the following problems. Okay? Now on the other side, on the left side, so you go to that side, on that arm, okay? What gives you the pressure? The gas gives you the pressure. In addition to the gas gives you the pressure, what else gives you the pressure? The liquid. Okay? So therefore you have that two parts. The gas pressure called the P gas. The liquid part called the pH. Okay? Any questions? Any step? Which step you don't understand? Why I have this equation? Why I have that P air or P gas? No questions? Okay. So then you want to find out the P gas, right? Do we do the P air? Do we do the air pressure? What is the air pressure for this first one?
760.
Okay, so here is 760, right? And let's see, the 760 is what? Millimeter mercury. Okay? Now let's assume those liquid is also mercury. Right? Liquid is also mercury. Okay? So therefore you can find out how much pressure was produced from this amount of mercury. But that depends on what is the H. In this first one, what is the H for this first one? 52 centimeters. Right? Now 52 centimeters, you have to convert into the same unit. So the air we use millimeters. And we also have to convert that into millimeters. Right? So I will use that to convert that centimeter is how much millimeters. I just write 520 millimeter mercury, so that will equals. Right? Do you know the P gas? Right. So therefore you have that equation. So the equation is like what I write there. Right? And then the next step you will just write P gas equals 760 minus 520. Well, that's to have the same unit. You do subtraction, you get 240. What unit we have? In millimeter mercury. That makes sense? Don't hesitate. Have any question, ask right away, because otherwise you get more and more accumulate.
Why is it, for the H, why is it millimeters mercury? Just because mercury is the liquid?
We assuming the liquid is mercury, right?
That's why it's.
Yeah, that's why it's
That's
also,
why you added
yeah, so
mercury.
if you have 52 centimeters, that means you will have 52 centimeters on top of your hand, and that will give you 50 centimeters of mercury pressure. Okay? Then you can convert that very easy, and 52 centimeters is 520 millimeters, so therefore, from the mercury itself, that will produce 520 millimeter mercury pressure. But in addition to that pressure, you also have the gas pressure. Okay? The gas pressure is always there on the top if you have that, have the gas on the top. And the air pressure always on the air on the top. Right? So let's do the second one. So second one, as I said, you will draw a line. This line you will draw from here. Let me draw a little more precise. Okay? So here is one pressure, here is other pressure. So let's see, this is P. Let me see, what is the, before I change the pen, what is the pressure as I right now, this red, that's red P, what is the pressure on the surface of that part. You just see what is connecting to that point.
The pressure of the gas.
The pressure of the gas, nothing else. Yes, yeah, very good. So we just call that P gas. We have that equal sign because we draw a line. Horizontal remains at the same depth. And then you don't have to worry, just know that is a line physics principle. So we have a liquid, and in my body, you draw the same line, same horizontal line, and that's the equation. And now let's see what is on the left side. And let me change the pen now. So on this side, we have also the P here. Okay? Another question here is what is the P there on that surface? This surface here. Even though right now it's not really surface because that is in the middle of the liquid. So imagine in the middle of the liquid, what are the pressure? The pressure will come from two parts. Okay? So one part is, how do we know that there are two parts? Because we have this open. If it's open, that means open to the air. So air will push on the top. And if the air push on the top, the air will also push at any depth. Any depth will have the air we have the pressure from the air. Okay? So therefore we have one part. I think here we call that an ATM, but I call that air, so that, sorry about that confusion. Okay? Right? So that comes from the air. Right? So then, what else produces pressure on this blue surface, on this blue middle point? It's also from the mercury, from this liquid. Okay? From this liquid. So the liquid, we'll call that a pH. Okay? Right? So again, I tell you this liquid is mercury Hg. So therefore, it's little convenient to converting them into the same unit. Obviously, you can tell you different liquid, but you have to convert. Right? So any question about this equation? So then let's substitute what do we know. Do we know the P gas? Do we know P gas? Do we know the P gas? You want to find out the P gas, so the P gas we don't know, right? Do we know P18M in this middle picture?
Yes.
What is the P18M? So that is 760 millimeter mercury. You know that. Millimeter mercury. Do we know the pH? pH depends on what is the height of that liquid. Right? How much pH do we have? Very good. So you have just plus 67 millimeter, depending on millimeter of what? Okay? So we'll do the lab. In this assumption, we are assuming that the liquid is Hg, so therefore we just write Hg. Okay? And this is a simple equation. Right? You want to find out P gas, just adding these two numbers. All right. Any questions?
67. Oh, okay.
67 is from the picture. This picture here tells you this is the H. Yeah. Very good. You have to ask the question. Don't just see like I will just later on I will study. If you can ask the question, why not? Well, yeah. Okay, good. So then let's see the last one. Okay. Last one again. Okay. What are you starting from? You are starting from like one line. See the line here, right? Or just draw this line here. Let's see, this time here is the pressure. Okay. What with the pressure right now? I write in this blue. That's the gas pressure. So therefore, I will have this P gas. Yeah, only the gas right now on the left side because as I draw there is no liquid on the top. So therefore equals whatever on the right side. On the right side, because this line is the horizontal, and the pressure should equal. Understand? So now let's change the plane. Okay? So here will be a different pressure. Okay? Now that pressure should equal to what? Look carefully what we have before. What is on top here? Okay, then what tell you the air there? What's the pressure of that air? Zero. Yeah, you can still write, you can see like this P ATM, right? Plus P what? What we used before? pH. But in this example, because this side here is closed, so when you close it, which means on this side, this surface is not subjected, is not under the influence of the air at all.
PATM is the same as PA?
Yeah.
Pressure, okay.
So you can see this. I think at the beginning I call that P air. PATM is atmosphere. Atmosphere is also air. All right. So then you again have this equation. Just starting from this equation, if we have those kind of questions, right? All right. So do we know the P gas? Do we know P gas? Again, we don't know the P gas. So we just write P gas on the left side. Do we know the PATM? Zero. So we have 0. And if you have a 0, you can use any unit. But you want to use millimeter mercury, you probably want to use centimeter mercury, right? But this pH is centimeter here. But let's use millimeter because millimeter is common. Right? Now let's plus the pH. If I use millimeter mercury, and right now you have that H is 103, 10.3 centimeters, so what do? You just convert that 10.3 centimeters by like 1 cm equals 10 millimeters, right? So you have 103, and not 10.3, right? Right. So I think you get the sense. Right? So therefore you just, the final answer was 103 millimeter mercury for the number 3. And after you get those answers, you can convert into different units. If you know this is 103 millimeter mercury, you can convert like in the first CRE into ATM or PSI or whatever those units. Right? Any questions? So make sure you have to you ask a question right away. Don't accumulate. All right. So very good. So you just so those are the just few of those practices. Right. So the next is we are going to study a few of those laws to give you that relation between the 4 variables. Remember we have that the pressure is 1 variable, right? And the temperature is another variable, and the volume and more. Okay? Right? So you can do different experiments depending on which variable you want to control. Okay? So in general, for a gas, you can have all the 4 can change. Okay? But you can control some of those. So like about 400 years ago, this guy doing some of those experiments. Okay? What he did is control the temperature, not changing, and control this N, not changing. Okay? By doing something like that, and you have this some of those tube, and you have this gas. That with the gas sample you want to study, and you can increase the pressure by putting more and more mercury. And if you put more mercury here, you will increase the pressure. As we studied in the last those manometer examples, the pressure there will increase. and you can measure how much pressure, how much liquid you have, how much air pressures, you can find the gas pressure, and then you can also find out, for example, the height of the gas, and the height is proportional to the volume. Understand? And you find out the equation or the relation between pressure and volume. Under the assumption, which means you keep that temperature constant, you keep that gas amount constant, because you're assuming you trap all the airs, you do the process kind of slow, so your temperature will not change. Right? So what he found out is you will have different pressures, you will have a different volume, and for a smaller pressure like 29, you have a larger volume. For a larger volume, you have a smaller, for a larger pressure, you have a smaller volume. When you do those data analysis, so what he did is take the pressure, multiply by the volume, and kind of very amazing, you find out, as we said, you have to control the temperature and N constant. And within the experimental error, you find out all the pressure times volume is about 1400. And obviously this number depends on the unit. So you have 1400, you might get 2000, depending on what unit you have. And you know, they all are the same numbers. Right? And so then you can represent your data by using a graph. You can plot in the pressure with volume, you get this parabola. If you want to see a better picture, you just take the pressure still as y-axis, and you do the inverse of the volume, so the volume become an inch, 1 over the inch cubic, or the inch to the -3, which means 1 over constant. And that's sort of the inverse volume, and you get this line that is straight. Alright, so after all those analyses, and the Boyle's law come out like this. So what Boyle study, you also going to study in my lab, is change the pressure of the gas, and then you will see the volume change. But you assuming the temperature is constant, and then how much gas you have is constant. Okay? And what you find out is mathematically, as you see in my table, is pressure times volume is constant. Okay? Or you can write a working equation. I mean, this equation will be the equation you use to solving most of the problem. You just write something like this. So P1 times V1 equals P2 times V2. Right? So you will have those different pair of numbers. So like in one table, you will see like one pressure is 29, then one volume about 48, another pressure at the bottom about 118, and then the volume become like much smaller numbers. But anyhow, all those multiplied together equals about 1400, right? Right. So this is one of those laws, okay? And we name them after some person. Okay? I will usually call them individual, because that's an individual person's name. Individual gas law. Okay? So there are quite a few different individual gas laws. Okay? Individual gas law is the first type. Okay? The second type, you pretty much summarize all those persons' law. And this is one good example. Scientific work is a teamwork. So one person finds the relation between pressure and volume. Another person finds the relation between the temperature and the volume. Another person finds the relation between N and volume. So then another person summarizes all them together into the so-called ideal gas law. Okay? And we are going to study all those, most of those gas laws, and we're going to learn how to use that. Okay? Right, so that is the first law, which is the Boyle's law. Okay. Right. Once you have that idea, you can see in different way. You can say because that pressure and volume is inversely proportional. Okay. So therefore, if you double the pressure, and your volume will cut into half. If you triple the pressure, your volume will become 1/3. Make sense? If you quadruple your pressure, your volume becomes 1/4. So that's just different way to see that. But sometimes you just don't want to see that. You cannot see that. You just write like P1 times V1 equals P2 times V2. So in this example, you see the beginning pressure is 1 atm, your volume is 1 liter. Okay? So volume and pressure is inversely proportional under the assumption the temperature is constant, the gas amount is constant. You can see these two assumptions is easily to achieve because you can close your container, so therefore your gas will not change. You can do the pressing or the expansion slowly. You do that very quickly. You pump up your bicycle tires, then your gas pump becomes very hot, right? Because that's where what we're studying in the next chapter. So we have those so-called PV work, right? And your pressure starting with 1, you have volume 1 liter. If your pressure becomes 2, you have volume become 0.5. And as we saw before, one equation to see this Boyle's law is P1 times V1 equals P2 times V2. So if we call that is our P1, this is our V1, and this is our P2, that is our V2. And obviously you can show that is right because you have 1 times 1 is 1, and 2 times 0.5 is 1. Right, so Boyle's law, you can use that in some of those real-life problems, for example, the diving. Okay? Just know when you diving into waters, and as we see in the problems of those manometers, okay? So you always have one pressure that comes from air. Okay? But if you diving into the water or into the liquid, so you will have more pressure coming from the water or the liquid, okay? Depending on how deep you dive into. Okay? And you figure out that for every 10 meters you dive below the surface, you will get 1 extra atm pressures. Right. So for example, if you dive in, let's say that guy, and get into the depth that is 20 meters, okay? So then the total pressure becomes 3 atm. Okay? So in among that 3 atm, 2 of that atm is come from that 20 meters of water. The other 1 atm is come from what?
Air.
From the air. And the air pressure always there, no matter how deep you get into the water. Right, now let's practice a few examples of use Boyle's law. As I said, you have to keep that T and N constant. So sometimes I will tell you that explicitly, but sometimes maybe not. So then you just identify what is your P1, what is your V1, and what is your P2, and what is your V2. Just make sure you make the right pair. And that is about those units. So as we said, we have these 4 variables. So we have 2 sets of equations. Depending on what set of equations you use, you can use, you can worry about those different units. So one is individual law, and the other one is ideal gas law. Individual law make sure the T in kelvins, and then P and V and N any units as long as you use the same unit. In the ideal gas law, you make sure the T is still in kelvins. So the pressure is in ATM and the volume in liters and N in moles. Then in the ideal gas law, you will have the ideal gas law that tells you is P times V equals N times R and T. Then you will have that R. Okay? And make sure your R should use that number 0.08206 and ATM times L and then mole and Kelvin, so that unit. Right. So I first tell those units because that's usually you will get confused. Now this Boyle's law are the so-called individual law. Individual law are those sometimes those person's name law. When you have those person's name law, we call that an individual law. Right. So individual law, how do you know to use that? So you will have two sets of conditions. Okay? You have these four variables, depending on which one is the constant. You might have two pressure and two volume. So when you have those kind of questions, you will usually think about use those person's name law. Right? You can see this example matching all those what we talked about. Okay? And we have one volume 7.25 L. You can start with volume 1. And we have two pressure, 4.52 ATM, and we have 1.21 ATM. Okay? So as I said, you have to make the pair right. If you call this 7.25 liter is our V1, you will see that V1 is at water pressure. Then you will call that pressure P1. Right? So that 7.25 liter is under water pressure. Right? So therefore, this pressure, you're going to call that P what? P1. Okay? And the other pressure will be our P2. Now this is what I said, you will have a two set of condition. Okay? So you can clearly see you have a two pressure. Okay? And you want to find out V2. Even though you don't know what is V2, but once you find out the V2, so therefore you have two sets. You have two volume, you have two pressure, so the two sets, or two pairs. Okay? So that is one hint. Okay? So you probably memorize all those equations like P1 times V1 equals P2 times V2, and P times V equals nRT, but you don't know which one to use. You use problems. So you can first examine how many of those variables do you have, and how many sets do you have. Do you have two pressure, two volume? Do you have two temperature, two volume? We have that. Think about use the person's name law. Sometimes the problem will give you some real confusion. Okay? Or give you two sets and give you some numbers, then you will see that actually one number is not changing. Right? So they're not really exactly two sets. Right. So once you have those name, just substitute. Okay? So we will substitute. We have P1 is 4.52 and ATM. Even though in this number everything is okay, you have the ATM and imagine like what you said here. So this law is kind of like a very restricted because you have to convert those temperature into Kelvin, your pressure for the ATM. Why that? Because you want to use this number. This number, I mean this R has these numbers. Right? So this R has this number, this R is called the constant. Okay? So for this number, it's kind of coincidence. You have that pressure in ATM and volume in liters, but you don't really have to convert those pressure into ATM. If the pressure is millimeter mercury or inch mercury, it's okay as long as you have two pressure have the same unit.
Is the answer 27.04? I mean, 0.08?
Let's see, yeah, you have that volume, so you will see the volume probably will become, well, you can see the volume, let's see, what did Boyle's law tell you? Boyle's law tell you the relation between pressure and volume. And that relation is what kind of relation? Is it directly proportional or inversely proportional? Inversely proportional, which means if the pressure increases, your volume what? Vice versa, if your pressure decreases, your volume will what? Okay. Now your starting pressure is 4.52, and compare your other pressure, which is larger, so your pressure decreases. What do you think? And your volume will what? Increases, right? 4.52 ATM, and this is what the volume. Okay, so then you continue on this side, 1.21 ATM here. And then V2 we don't know. Okay? Right, that is a similar equation you can solve for V2, right? And so let's see, V2 will equals 4.52 ATM times 7.25 L divided by 1.21 ATM. And you can see the ATM cancel out. This is the reason when you use this equation, you don't have to start with ATM. If you use mercury will cancel out. Understand? If you use PSI for the pressure, the PSI will cancel out. Even you don't have to convert. All right. So what we get is 4.52 times 7.25 divided by 1.21. So you get 27.1, and the unit left over is a liter. Am I right? All right. Any questions? Do a practice. Okay? So what kind of equation gives you? Okay? What is changing? How many are changing? You have one set, you have two sets. Okay? If you see the changing is about pressure and volume, you use Boyle's law. Now this problem is a bit more than what we just studied for the examiner. Okay? So you have to use this last statement. Okay? One ATM is also from like 10 meters of diving. So every 10 meters you diving into the water, you will increase 1 ATM. All right. So what's the answer? Is it D?
E.
Very good. So that's answer E, right? You want to see like how you get E? You okay? Alright, now let's assign those numbers. So we have 19 ml, right? There's 7.5 ml, and that clearly tell you are two volume. Okay? So if you call this is V1, okay? And then you will see what is your P1. That one pressure is V2. One pressure is this. Okay? If you call this 19, okay? If you call that 19 ml is your V1, so what do you call this 1.0 ATM? Your P1 or P2? Or P1, but this 19 ml is under the pressure of 1 ATM. Now if you call that 19 ml is your V1, so this 7.5 ml should be our V2, right? And then we don't know P2, so therefore become our unknown. Right, now how many pressure we will have, how many volume we will have? We have 2 pressure, 2 volume. Right, so that's, I said, you have 2 sets. Right? The 2 sets, you think about use those persons name law. Right? So right now you have the pressure and volume, which means we keep T and N constant. Right? So just T1 times V1 equals T2 times V2. Okay? So after you have this equation, you substitute and you find out T2 equals what? 2.5 ATM. Okay? Now why that the depth is 15 meters? 15 meters give you how many? So 15 m water. Right? So that'll give you how much pressure? That'll give you 1.5 ATM. And your total pressure is 2.5. So where's the other 1 ATM come from? The other one comes from the air. Right? So plus 1 ATM from what? From air.
Can you repeat the last of this?
Okay? So after you calculate, you find out that T2 is 2.5 ATM. Right? And then you will say, what is the depth? How deep is that depth? Okay? And you don't use all the 2.5 ATM because they tell you for every 1 ATM is 10 meters. If you do diving, so every 10 meters you dive in, you increase 1 ATM. Right? So at some depths you have a 2.5 ATM. Okay? 2.5 ATM, don't forget you subtracting 1 ATM from the air, because if the water is going into the air, okay, so the air will give you static without water. Okay? Here is the air. Okay? The air will give you 1 ATM. If you here, and here it dive in. Okay? So if here the pressure is 2.5 ATM. Okay? So this 2.5 equals 1 plus the pressure from the water. Right? Understand? Kind of? So from this you can find out very quick. So the pressure from water equals 1.5. And then you use this equation. So for every 1 ATM, that's 10 meters. You find out that 15 meters. Very good. So I see that. You got it? Okay, so the next person's law is Charles' law. Okay? So those, we are going to study those in the videos. So you will see the Boyle's law, Charles' law, and then another law we're going to study is Avogadro. But some other person's law is called the Guy Leucet. So we are not going to study all those person's law. We are going to study the first person, Boyle's, Charles, Avogadro's, And then we will just move on to this ideal. Okay? Ideal gas is kind of like summary. Okay? All the percents into one equation. So therefore we can do the reverse. If you have ideal and you do like what law is keep what constant, and you just like control some of those variables as constant, and you can go back to those individuals. Right? So this view is very important. So try to memorize how to use what law, and in what law use what unit. Right. So prepare for the lab. We do the lab Thursday. Do the titration. What about the exam? Right. Right. So study the CRE. Okay. That is very important. And if you have time, also study those quiz at the end of each chapter. Right? If you need help, and you can send me an email about the test.
I have a question. At the end of chapter 3, you did these problems where you had to know like the radius of a sphere and like volume and stuff like that. You get to know that kind of stuff for the test.
You can do those later after you feel very, very comfortable with all the others.
Is that going to be on the test?
Maybe, but that's not important. But not that important.
So just study everything.
Everything's on the test.
He's gonna dodge any questions.
So we're coming in regular
It's better to
time.
get all the other questions right than
Yeah,
that one.
I will be here for ready if you come here.
I'd rather get all the questions.
That last I know I have to test tomorrow, I have to worry about first.
Yep.
One more question. Our final covers everything, right?
Yeah, find out cumulative.